Right, it is day 1 of chapter 4. We do not spend a ton of time in this chapter, and the good news is that today there are no proofs. So we are talking today about the midpoint formula and the distance formula. So starting with distance formula, this tells me the distance between 2 points, or the length of the segment made by joining those 2 points. So we are going to use this formula, square root of x2 minus x1 squared plus y2 minus y1 squared. And we're going to use that first to find the lengths of the sides of this triangle. So let's find ED first. Side ED. So D was my second point, so I'm going to let this be my x2 and y2. And this will be my x1 and y1. So I find that length by taking 2 minus 5 squared plus 3 minus 7 squared. So once you have your x1, x2, y1, y2s in the correct places in your formula, it's just order of operations from there. So I need to take care of what's inside my parentheses first. 2 minus 5 is negative 3. 3 minus 7 is negative 4. Negative 3 squared is 9. Negative 4 squared is 16. 9 plus 16 is 25. The square root of 25 being 5. So ED is 5 long. Okay, next I am going to find the side EF. So I'm going to now find EF. So following the same steps, if that's my x1, y1, this will be x2, y2. And I'm going to plug those values back into my formula. So that's going to be 9 minus 5 squared plus 4 minus 7 squared. And again, order of operations, 9 minus 5 is 4. 4 minus 7 is negative 3. So again, that's going to be 16 plus 9, which is 25. The square root of 25 is 5. So this side is also 5. Now I need to lastly find side DF, and I'm running out of room, so I'm just going to move up here to find DF. And this time F is my x2, so this is going to be x1, y1. 9 minus 2 squared plus 4 minus 3 squared. 9 minus 2 is 7. 4 minus 3 is 1. 49 plus 1 is 50. Now, 50 is not a perfect square. What I do not want you doing is typing the square root of 50 into your calculator and giving me a decimal answer. I want a simplified radical. A factor of 50 that's a perfect square is 25. So I can take out 5 and leave the square root of 2. And this would be an isosceles triangle because these two sides are the same length. Okay. Distance formula. On to midpoint formula. If I have two coordinates, let's look at this example. A is at 1, 3, and B is at 9, negative 5. And I want to find the midpoint of the segment joining those 2 points. I can just use my midpoint formula, which is the sum of your x values divided by 2 and the sum of your y values divided by 2. This gives you the coordinates, the location on your graph of the midpoint. So that's going to be 1 plus 9 over 2, comma, 3 plus negative 5 over 2. 1 plus 9 is 10, divided by 2 is 5. 3 plus negative 5 is negative 2, divided by 2 is negative 1. So 5, negative 1 is the location of my midpoint. So those are the two formulas you need to memorize, and we are going to use those to now talk about median. If I am given a triangle on a graph, I can find the equation of the median by following these 4 steps. First is to find the midpoint of the opposite side, because remember, a median is drawn from the vertex of the triangle to the midpoint of the opposite side. So I use midpoint formula to find the midpoint. Then next I want to find the slope between the vertex and the midpoint. So that's just your y2 minus y1 over x2 minus x1 formula. Then I need to find the y-intercept using either my vertex or my midpoint, and I'm going to write my equation, and we're going to use point-slope form for this. Or sorry, slope-intercept form. Y equals mx plus b. So I need my slope and my y-intercept to write the equation that way. So let's start with this triangle PQR. I need to plot my points. P is at negative 5, 3. Q is at 3, 7. And R is at 1, negative 3. And if I connect those three vertices, that forms my triangle PQR. Negative 5, 3, 3, 7, 1, negative 3. So step 1, I need to find the midpoint of the opposite side. So if I'm doing median RM, that means it's going to be drawn from R to the midpoint of the opposite side. The opposite side being PQ. So this is the side I need to find the midpoint of. I need to find the midpoint of PQ. So I'm just going to use my midpoint formula. Add your X values, negative 5 plus 3 divided by 2. Add your Y values, 3 plus 7 divided by 2. Negative 5 plus 3 is negative 2, divided by 2 is negative 1. 3 plus 7 is 10, divided by 2 is 5. So that is my midpoint, negative 1, 5. So connecting those 2 points gives me my median. And now I'm on to step 2, which is to find the slope. So I'm going to use my slope between the R vertex and my midpoint. So this is going to be x1, y1. Here is x2, y2. So 5 minus negative 3 over negative 1 minus 1. It's going to be 8 over negative 2, which is negative 4. Now that I have my slope, I need to find my y-intercept. So I'm going to substitute my slope and the x or y value from either R or M into this equation to solve for B. I'm just going to use R. So here is x, here is y. Negative 3 equals negative 4 times 1 plus B. Well, negative 4 times 1 is just negative 4. So if I solve for B, I add 4 to both sides, and I find that B is 1. So now the equation for my median, now that I know my slope and my y-intercept, is y equals negative 4x plus 1. And that's it. We used midpoint to find the slope, and then we used our slope and a point to find the y-intercept, and I had all the information necessary for my equation. Okay, on the back we are just going to do a little bit more practice with midpoint and distance formula. On these first two, we are now given an endpoint and the midpoint, and we want to find the other endpoint. So essentially what this is giving you is your x1, y1, the midpoint, and you need to find x2 and y2. So remember, your midpoint formula is this. So let's look at each value individually. The x value for my midpoint is negative 5, and that comes from this calculation, x1 plus x2 over 2. So negative 5 is equal to 1 plus x2 divided by 2, and I'm going to solve this equation for x2. First, I multiply both sides by 2. I subtract 1, and I get that x2 is negative 11. I'm going to repeat this for my y value, which is 4. And that comes from this operation, y1 plus y2 divided by 2. So if y1 is negative 3, I can solve for y2. First, I'm going to multiply by 2 on both sides. And then I'm going to add that 3, and I find that y2 is positive 11. So the coordinates of the other endpoint are negative 11, comma 11. Let's do this one more time. This is x1, y1. The x-coordinate for my midpoint is 1. So negative 4 plus x2 divided by 2 gets me that value. So again, multiply by 2, add 4, and I get that x2 is 6. Now I'll do our y value. Negative 2 is equal to negative 4 plus y2 divided by 2. Multiply by 2, add the 4, and y2 is 0. So the coordinates of my other endpoint for that problem are 6, 0. Okay, just a little more distance formula practice for you. If this is x1, y1, and this is x2, y2, remember distance formula, x2 minus x1 squared plus y2 minus y1 squared. 3 minus negative 1 squared plus 0 minus 8 squared is what's inside my radical. That becomes plus, so 4 squared plus negative 8 squared. That is 16 plus 64, which is 80. This can be simplified, 16 times 5, so 4 square root of 5. Okay, one more like this, x1, y1, x2, y2. Distance formula, 5 minus 1 squared plus 0 minus negative 7 squared. That's going to be 4 squared plus 7 squared, which is 16 plus 49, which gives us the square root of 65. 65 is not a perfect square, and it does not have any factors that are perfect squares, so it stays like that. Okay, last one, we have a graph, so I need to identify my points. This is -4, -3. This is 0, 2. So that's going to be my x1, y1. This is going to be my x2, y2. So the distance between those points, 0 minus -4 squared plus 2 minus -3 squared. That becomes plus and plus. So I get 4 squared plus 5 squared, which is 16 plus 25. And that gives me the square root of 41. 41 is a prime number, so it's not going to simplify. And that will conclude our day 1 notes from chapter 4.